So hello everyone, today I'm going to discuss how to find a eigenvalue of covariance matrix, and out of the possible eigenvalues, which one is the maximum eigenvalue, that I am going to discuss. So again, this particular numerical is related to PCA calculation, okay, and this numerical I have picked up from weekly quiz of the NPTEL course DeepLearning. Okay, so here I am given three data points, x1, x2, and x3 in vector form. As you can see, x1 is 2 2, x2 is 1 2, x3 is 2 1. Okay, so what are the steps to find out the maximum eigenvalue of the covariance matrix C? So this particular covariance matrix I will be calculating by taking reference of this x1, x2 and x3 data points. Okay, so here what is the first step? I will be first calculating the x bar, that is the mean of the data points. Okay, and then after that I will be calculating what? I will be calculating the covariance matrix. So in the calculation of covariance matrix, what is the requirement? I need the data points, all the available data points from I equal to 1 to n, and then I need the mean value, right, that I have calculated previously. Okay, so in a previous video I already have shown how to calculate the mean value, and the output only I am sharing here. The output here was 1.67, 1.67, and in a different video even I have calculated the covariance matrix C. Okay, and what is the final output of this covariance matrix? That is 0.22 minus 0.11 minus 0.11 and 0.22. Okay, so after calculation of the covariance matrix, I have to now find out the maximum eigenvalue. Okay, now to find out the maximum eigenvalue, I have a equation. So what is the equation? The equation is a minus lambda multiplied by I, then determinant of it equals to 0. Okay, so here as you can see, this A is a matrix, it's a symmetric matrix. Okay, so my covariance matrix is also a symmetric matrix. So here the in place of A I will just replace the C matrix, my C matrix, and what is this lambda is denoting? The lambda is will tell me the eigenvalue of the covariance matrix. Okay, so this lambda I have to find out actually. And then what is this I matrix? This I is nothing but an identity matrix. Okay, where the diagonal values are same, one, it is 1 1. Okay, because my covariance matrix is of size 2 by 2, my identity matrix will also be of size 2 by 2, where this diagonal elements will be 1 1 and rest of the values will be elements will be 0. Okay, then let us proceed on calculating this one. So what I have to calculate first? I have to first calculate the determinant. Okay, this particular symbol is nothing but the determinant. This A, as I am going to replace it with the C matrix, so that is 0.22 minus 0.11 minus 0.11 then 0.22. This is my matrix C, my covariance matrix C. Lambda is the unknown value for me, I have to find out the lambda values. I have, but the identity matrix I know 1 0 0 1. Okay, so all these value, this from on the operations that I am going to do here, I will find on this matrices, then I will be finding the determinant, okay, which is equal to 0. Okay, so what will be the next step here? The next step will be what I have to do, I have to element wise multiply this lambda value, right, with my identity matrix, and then finally subtract my identity matrix value from my covariance matrix. So the covariance value, that is 0.22 minus, here it will be lambda. Why? Because the first covariance matrix element will be subtracted by the first element of my identity matrix multiplied by this coefficient lambda. Okay, this is the first element. Then what is the second element here? For the second element of my covariance matrix is minus 0.11, whereas here the second element will be only 0. 0 multiplied by lambda will be 0. So it will be as it is, minus 0.11. Similarly for this one as well, it will be minus 0.11. Then the last element will be 0.22 minus lambda. So I have to find out now determinant of these particular matrix. Okay, so let me calculate it in the next page here, or I'll finish this till this step in the previous page only. So what I will be having here, I will be having these two elements multiplying 0.22 minus lambda, both the elements are same, so square, then minus, this is the way to find out the determinant of a matrix, minus, what are the values here, minus 0.11 multiplied by, or I can take just square of it, yes, equal to 0. So let's finish the rest of the computation in the next slide. So till now what we have, I have 0.22 minus lambda whole square minus 0.11 whole square equal to 0, right? Let me just divide the space here, equal to 0.22 whole square plus lambda square minus twice of 0.22 multiplied by then lambda, right? And here the last one, it will be 0.0121, yes. So this value will be now 0.0484 plus lambda square is still there minus 0.44 lambda, and lastly minus 0.0121 equal to 0, right? So what will be the final value here, lambda square minus 0.44 lambda and plus, okay, these two value I will subtract, the final value here will be 0.0363 equal to 0, right? So how to now find out this lambda value? Here this particular equation is of the form what, ax square plus bx plus c equal to 0, right? And in this type of equation, how I find out the root of this x value, the unknown value, that is how x equal to minus b plus minus root over b square minus 4ac, right, divided by twice of a. Okay, so that only I am going, this particular formula here I am going to replace for my equation here. So first will be minus of 0.44 plus minus root over minus 0.44 whole square minus 4 multiplied by here it is multiplied by 1, right? So 1 multiplied by the the last value is the C value is 0.0363. This all square root divided by twice of 1, right? Because your A value is 1. So what will be the final value here? Just some calculations here that I am doing. 0.44 plus minus within the square root, I'll be having 0.1936 minus 0.1452, yes, and I'll divide it by 2. So then what will be the next value? 0.44 plus and minus both are there, right? And this square root final computation value will be 0.22, which is divided by 2. So there will be two values, right? One will be I'll be adding and one will be subtracting. So those two values are 0.33 and 0.11. Okay, so I have finally got my value for this unknown variable lambda. Okay, and those two values are 0.33 and 0.11. And this lambda is not a simple unknown variable, but this lambda is my eigenvalue for the covariance matrix that I have taken, for the covariance matrix C. Okay, so what are the values, eigenvalues I have got? 0.33 and 0.11, right? So let us go back to the previous slide and see the available options for my question. So the question is maximum eigenvalue of the covariance matrix C, right? So the options are 0.33, then 0.67, 1 and 0.5. And from the answers of lambda, the values of lambda that I have got, I have 0.33 and 0.11, right? And out of these two values, 0.33 is the larger value or the maximum value. So then the correct option will be 0.33, option A, 0.33. Thank you.